Good evening, everyone. We're going to get started here in just a second. Let me um, get a few things running. Okay. I forgot to press the record button on the first part of the lesson tonight, so I'm re-recording it, and it's just going to be me, myself, and I. So if you'll give me just a second here, we'll get session 3, module 3, part 2 going. Appreciate everybody's patience tonight as we get this set up and operating. All right, I think we're ready to roll now. Again, this is session 3, module 3, part 2, and we're going to start with components, protective components. And I think everybody can see that. And we're going to continue to share the screen. And I've actually got myself signed in twice so I can kind of monitor what you're seeing so I'll make sure we got everything on the screen. Protective components are things such as fuses and circuit breakers that are used to protect equipment from damage or safety hazards such as a fire or electrical shock. They're designed to remove power in case of circuit overload. Fuses blow, and that's a one-time protection. And when we mean blow, they have a little metal strip in them, and they usually will burn in two at a certain overload and protect the circuit from damage. Circuit breakers trip, and they can be reset and reused. A fuse is a one-time use. Fuses interrupt circuit overloads by melting a short length of metal. When the metal melts, the current path is broken and the power is removed from the circuits. Replacing a fuse or circuit breaker with one with a higher current rating could allow the fault to permanently damage the equipment or start a fire. So when you replace a fuse, you want to make sure you use the same rating. So if it's a 5 amp fuse, you want to replace it with a 5 amp fuse. If you replace it with a 20 amp fuse, it would definitely let more current into the circuit and it could start a fire or damage your equipment. Same thing with a circuit breaker. They, from time to time, will go bad. So if you have a 15 amp circuit breaker, you want to replace it with a 15 amp circuit breaker, not a 20 amp. Here's some schematic diagrams of what a fuse would look like, and this is a good representation. It's got a little metal strip between two contacts that will burn up if the circuit is overloaded. A circuit breaker will trip, a little switch will kick it off so that you can reset it once you determine what caused the fault. Here's some example of fuses. This is a glass fuse. There's a little thin metal strip between the two contacts here that if it's overloaded, it will burn up and you can visibly see that. Same thing here. They used to be used quite commonly in automobiles, but now they've uh, transition to what we call a blade fuse, and it's two metal blades that go up into a piece of plastic, and the blades are connected again with a thin strip of metal. And if it exceeds the current rating of the fuse, that metal will burn in two, and you can see it. You can kind of see in this diagram right here the little metal strip that runs between the two blades. Here is a typical household circuit breaker. It's rated at 15 amps. They will have the amperage rating on the little toggle switch. And if it flips, some of them even have an indicator that will turn red to let you know that's the circuit breaker that has tripped. Here's a ground fault circuit interrupter or circuit breaker. You use those in your household panel uh, for uh, places where water would be, such as outside. You would have, if you have an outside outlet, it's probably going to be on a ground fault breaker. Nowadays, a lot of the outlets themselves have a ground fault breaker built into them. Here are some practice questions that we'll go over. What is the electrical component, or what electrical component is used to protect other circuit components from current overloads? Is it a fuse, whatever that word is, variactor, or all these choices are correct? Well, we know it's not all of them. It has to be A, the fuse. We talked about that just a few seconds ago. What is the purpose of a fuse in an electric circuit? To prevent power supply ripple from damaging a component, to remove power in case of an overload, to limit current to prevent shocks, or all of these choices are correct. Again, it's to remove power in case of an overload, and it's going to be B. Why should a 5 amp fuse never be replaced with a 20 amp fuse? Well, the larger fuse would be likely to blow because of it's rated for a higher current. Nah, that's not correct. The power supply ripple would greatly increase. Excessive current could cause a fire, or all these choices are correct. Well, we know they're not all correct. The correct answer will be C, because the higher rated fuse would allow more current into the circuit, which could overheat the circuit and cause a fire. So the answer is C. Circuit gatekeepers, switches and relays. Switches and relays control current through a circuit by connecting and disconnecting paths for the current to follow. Switches and relays are described by their number of poles and the number of throws. The combination of poles and throws describe the switch. Each circuit controlled by a switch is a pole. So the circuit that has a switch in it is called a pole. Each position of the switch is called a throw. A switch is operated manually, while a relay is a switch controlled by an electromagnet. So when you walk into a room and you've got an overhead light like I do here, you flip a switch, you flip it up, and the light comes on. You're closing the circuit to make the light glow. Here's a diagram that illustrates the different types of switches. One is a single pole, single throw. It's a single circuit, is switched on and off. A single pole double throw, so you got this one, it's very similar to that, but you also have the option here. It's a single circuit that is switched between one or two other circuits. Then you have double pole double throw, and it's an electrical switch that controls two separate circuits at the same time. So you've got this circuit and this circuit, and you got this circuit and this circuit. Then you have push button. A push button is just a switch that you can push down to close the circuit, and it comes on. You release, it comes off. Over here are some examples of different switches. Here's a row of switches, and you've seen these in a lot of early computer circuits. They were called dip switches, and you could set those to control different circuits. In older radios, they may have had some dip switches as well. Then finally, this is an example of a relay. A relay can either be on when current's applied to it, or it could be off. So it depends on how the relay is wired. Indicators, meters, and displays. Indicators and displays are important components of a radio. An indicator is either on or off. A meter provides information as a value in the form of numbers or in a numeric scale. A display combines indicators, numbers, and labels. A liquid crystal display, or LCD, is used on the front panel of many radios and test instruments. If you're looking at a computer screen watching this, you're more than likely watching an LCD. Here's an example of an HF radio, and this would be an LCD screen. It has numbers on it. It can have graphs on it, It also can have buttons, and so an LCD can be very versatile on a HF radio. Some practice question. What is the function of a single pole double throw switch? It's a single circuit is opened or closed. Two circuits are opened or closed. A single circuit is switched between one of two other circuits. Two circuits are each switched between one of the other circuits. And it's going to be C. A single circuit is switched between one or two other circuits. What type of switch is represented by component 3 in figure T2? All right, there's component 3. You notice it's a single pole, single throw, so it's going to be a switch. And the answer would be A, single pole, single throw. What is a relay? An electronically controlled switch, a current-controlled amplifier, an inverting amplifier, or a pass transistor? Well, we studied just a few seconds ago, and it's an electronically controlled switch. Which of the following displays an electrical quantity as a numeric value? Is it a potentiometer, a transistor, a meter, or a relay? Well, we talked about different meters in earlier classes, so it's going to be C, meter. All right, here is schematic symbols for all the different types of electronic components that you might run into on a schematic diagram. Some that I know that the technician material will test you on is resistors, and the symbol for a resistor is a little squiggly line. This is a potentiometer, which means it's an adjustable resistor. If you have a radio in your car and you turn, if it has a volume knob, a lot of them don't anymore. They've got buttons on the steering wheel. But if you have a volume knob on your radio and you turn up the music, you're using a potentiometer. So it's a variable resistor. Capacitors, you need to know this symbol and this symbol. Inductors, that's an air core, means it's just a coil of wire. An adjustable inductor has a line through it. A magnetic core would be, it's wound around some type of metal. And then you have an adjustable inductor. Relays, I don't think you'll see much of that on the technician test. Diode, the one that you do need to know, forward voltage with the little arrows. They can be straight or they can be squiggly. When you see arrows coming off of that, that's indicating an LED diode. These, if you get into general and extra class studying, you'll run across these. And then transistors, you just need to know for the test the different transistors. I don't think you'll be questioned on the exact type, but you just need to know that that's a transistor. And then, of course, we've talked about the switches. Here are some more schematic symbols that you need to be familiar with. Single cell, like a AA battery, could be represented like this. A multiple cell battery could be a car battery, a battery that you would, lithium iron phosphate battery that you would use to power your radio would be multi-cell. These symbols represent grounds. Literally, in your house, from your electrical panel, there's a copper wire that's running from that electrical panel outside to the outside of your house, and there's a big metal rod that the electrician drove in the ground, and that copper wire is attached to that metal copper rod, and that's your earth ground. And so every house would have that. A chassis ground would be a ground that's attached to the chassis of, say, a radio or an appliance or something like that. Circuit interrupter, circuit breaker, fuse. Antenna would be another one that you need to be familiar with. And then incandescent light lamps, that's a symbol that you will see. Symbols are used when drawing a circuit because there are so many types of components. Schematic diagrams are visual descriptions of a circuit and its components that uses standardized drawings called circuit symbols. It shows how the components are connected electronically. All right, some practice questions on this. What is the name of an electrical wiring diagram that uses standard component symbols? Is it a bill of materials, connector pinout, a schematic, or a flow chart? And the answer would be C, it's a schematic. What is a component? What is component 1 in figure T1? Well, we just looked at those a while ago. That is a resistor. So its answer is going to be A. It's not a transistor. This is the transistor. C is battery. So this is the symbol for a battery. And D is connector. So the answer is going to be A. What is component 2 in figure T1? Well, we just went over that. It's not a resistor. That's the resistor. It's a transistor. Indicator lamp is this one. And a connector would be just the wire connecting the two, or a connector that you would use to attach the wire to something. So the answer is B, it's a transistor. What is component 3 in figure T1? Well, we looked at that a while ago. That's a lamp. So it's not the resistor. So that's what the resistor is. The transistor is this. C is lamp. So that's what that is. The ground symbol would be one of these. And so the answer is going to be C, lamp. What is component 4 in figure T1? Component 4 is a battery. That's a lamp, a transistor, a resistor, a ground. So we got resistor is this. Transistor is 2. Ground symbol is any of these three. And D is battery. So that's the answer for this one. What is component 6 in figure T2? Component 6, all right. Is it a resistor? No, a resistor is right here. Is it a capacitor? Yeah, it's a capacitor. Is it a regulator integrated circuit? I don't see one of those. Or is it a transistor? And I don't see a transistor in this drawing. So it has to be B, capacitor. So number 6 is a capacitor. What is component 8 in figure T2? Well, remember a while ago we said a diode looks like this, and you've got the little squiggly lines coming off, meaning it's emitting something, and that something would be light. So it's not a resistor. There's the resistor. It's not an inductor. Here's two inductors, and it's actually together that makes a transformer. It's not a regulator integrated circuit. It has to be D, the light emitting diode. So that's a diode, and it's emitting light. What is component 9 in figure T2? All right. We know it's some kind of resistor, but it's got the arrow indicating that it's variable. So is it a variable capacitor? No, we've already identified it as a resistor. Is it a variable inductor? Nope. Variable resistor? Yep, that's the answer. Or a variable transformer. So the answer is C, variable resistor. And I'm clicking too quick here. What is component 9 in figure T2? So we're looking, oh, I must have went backwards. All right, so it's a variable resistor. What is component 4 in T2? Is it a variable inductor, a double pole switch, a potentiometer? Nope. Transformer. And the way to kind of give you an idea on this, this is a household current. You've got a circuit here with a fuse and a switch, and over here you've got low voltage components. So it's transforming 120 volts probably down to about 5 volts or 12 volts. So it's a transformer. So it's transforming the current, the voltage from one amount to a smaller amount. So it's a transformer. So it's a D. What is component 3 in figure T3? All right, we know it's an inductor, and we've got an arrow on it indicating that it's variable. Is it a connector? Is it a meter? A variable capacitor? Nope, it's not a capacitor. It's a variable inductor, so the answer is going to be D. What is component 4 in figure T3? So component 4 is right up here, and that looks kind of like an antenna to me. So is it A, antenna, B, transmitter, C, dummy load, or D, ground? And the answer is going to be it's an antenna. Which of the following accurately represented in electrical schematic? Which of the following is accurately represented in electrical schematics? Wire links, physical appearance of components, component connections, or all of these are correct. And it wouldn't be wire links, and it's not the physical appearance of the components. It's going to be the component connections. All right, let's talk about radio circuits real quick. An oscillator is a device that produces a steady signal at one frequency. It's used in both receivers and transmitters to determine the operating frequency. The process of combining data or voice signals with a radio frequency signal is called modulation. Modulators add the data or voice signal to the radio frequency signal or carrier. So modulator adds it to the radio signal. A demodulated circuit will extract the information from the modulated signal. Mixers combine two RF signals and shift one of them to a third frequency closely related to a modulator. Here are some practice questions. What is the name of a circuit that generates a signal at a specific frequency? We just talked about that. It's not a reactance modulator, not a phase modulator, not a low-pass filter, but it's de-oscillator. It creates a signal at a specific frequency. Which of the following describes combining speech with an RF carrier signal, radio frequency carrier signal? So we're combining speech or data. Is it impedance matching? Is it oscillation? How about modulation? Or D, low-pass filter? The answer is going to be C, modulation. You're combining speech with a carrier signal, or you're combining data with a carrier signal. Which of the following is used to convert a signal from one frequency to another? Is it a phase splitter, a mixer, an inverter, or amplifier? So you're converting a signal from one frequency to another. It's going to be B, mixer. And that's the end of Module 3. Thank you for being here tonight. We'll start Module 4, Part 1 here in just a minute. Thank you and have a good evening.